Hello everyone, my name is Vanessa Thornton and I'm here today to talk you through some best practices and design patterns for developing serverless applications at scale. So I've been a developer for 5 years now, and the last 3 years I've spent my time working at Xero. I've actually shifted teams, so I'm no longer in the API team, but the last 2.5 years I was. And we deal with lots and lots of requests. We're talking millions of requests coming in to the public API every month. And for the last 2.5 years, I spent the majority of my time trying to build out serverless applications to help us scale with those requests coming in to the public API. So just to give you some context around what I've been working on, we currently used to have ingress coming in through our public API gateway, and that was a monolithic application served on EC2 machines. And with millions and millions and millions of requests coming through, we saw that even with load balancers and auto-scaling policies in place, that by the time that our auto-scale policies kicked in, another EC2 server spinning up would take roughly about 10 to 15 minutes to become available to start serving traffic. And by that time, when our customer requests were ramping up, it was sort of like late to the party. It was kind of like, I'm here to serve requests, but all of that traffic is now sort of been banked up and processed by the other machine, so it was a bit too late. So what my team was tasked with was to build a serverless application that we could stop people polling for information, because the problem is that they didn't know when their customers were making changes in the front-end product. So they kept doing GET requests, oh, has this information changed for my customer? So we wanted to build a webhook solution where we could send information to them saying, hey, something has changed for your customers. So that would alleviate the need for all of the GET requests coming in to the public API and leave the request for actually posting and putting data into our platform. So we send about 1 million invoices produced by Xero every hour coming through the system. In the public API, we had 700 applications subscribed to our webhooks platform, and we were tasked with delivering the messages in under 10 seconds from an end user raising an invoice in the front-end system to delivery to our third-party application. And we have one of our biggest subscribers, which is Vend. If you heard of them, they're a point-of-sale software integration company, and they currently have over 20,000 active Xero organizations that will trigger webhook events, so we needed to be able to serve that data coming through. And we learnt that through serverless applications you can scale while you sleep, which is awesome. So initially in August 2018, we started seeing 7,359,201 messages going through webhooks, which led to, in January 2019, 9,326,441 messages. And as of a couple of days ago when I pulled this data, July 2019, we're in August now, but this is when I did the report, we're now serving 20 million, just over 20 million webhook messages delivered to our third-party apps per month. And this all happened while the team was sleeping/working on other projects. And it was only from monthly reporting that we knew we had grown so much in such a little time. And this was achieved with the use of a few lambdas. We're talking about 5 or 6 lambdas, and harnessing the power of streams and queues, which I'll talk a little bit later in this talk. So the overview of what I'm going to be covering today is what is scale in the serverless world look like, ways to achieve that scale, and how to predict the future. So I'm going to open with a quote, which basically just says here, just because your applications are hosted by a cloud provider does not make them, the cloud provider, any better at making computers. And we're actually only limited by the limits of what the physical hardware can do. However, we can do so much with just a few small changes and following some best practices and design guidelines, and you can deliver great scale. So let's have a look at the first section, which is scale in the serverless world. It is a shift in thinking. And here's another quote. Serverless is one of the hottest design patterns in cloud right now. Even though that this was, quote, was stated in 2018, it still holds strong today. Serverless functions such as lambdas are nothing new, and in fact they were launched 4 years ago, or nearly 5 years ago in 2014. But it's the surrounding services that make the serverless ecosystem what it is today, and that is only a few years old, maybe like 3 years old now. And if you were an earlier adopter of serverless like me and my team, then you would understand that it's hard to develop applications when best practices and design patterns were pretty much non-existent at the time. So fast forward to today, and you're only one Google search away or one conference talk away from gaining insight to the best practices and patterns. Today we're going to look at one problem in particular, which is scalability, and how we solve that using good design patterns. You might be thinking, wait, what? Don't we get scalability for free just by building serverless? The answer to that question is yes, you do, and no, you don't. Let me explain. So, problem. You're applying monolithic scaling principles to a serverless architecture. The solution is shifting away from total number of requests and how they get handled to a focus on how your system handles concurrency. So let's look at scale as a definition in the serverless world. So we know the concept of horizontal scaling, and that is growth in numbers horizontally, and that looks like the number of lambdas invoked or containers spun up or functions executing to quickly serve a spike in user traffic. But what if we flip the focus of what it looks like and we focus on something I deem the concurrency zone? What is a concurrency zone? It's still scaling horizontally, but you have to ensure that your path or your pipeline of where your data is going is wide enough to avoid bottlenecks. And we want to be able to design our systems to handle concurrency rather than the numbers of requests, because your cloud provider will handle that for you natively. That will scale horizontally. So now that we know how we can shift that thinking in the serverless world, we see another problem when you start building out your serverless applications. You start seeing bottlenecks in your applications, so that's our next problem. Let's have a look at this in a detailed diagram. So here we have a common serverless application pattern where you have an API gateway, and that is backed by a Lambda, and this connects to a data store. In this case, it's an Amazon RDS database. Doesn't matter what flavor it is, it's just a database. So we understand that this pattern will scale horizontally as each new invocation coming into the gateway will spin up a new Lambda and function to serve your incoming requests. That is true. But what happens when it's time to store our data in a data store? Our databases do not scale horizontally with each request. We get assigned a connection and a connection pool, and connection pools have finite limits. And therefore, we've created ourselves a bit of a bottleneck because we can't control that. So how do we solve that problem? You decouple your architecture by moving towards an asynchronous model. So to look at this, we have a cloud-native design here. And to solve this, we need a mechanism to account for that bottleneck that you saw from the previous diagram where the Lambda was connecting to a connection pool, which is finite for the database. We can do this by either adding a stream or a queue, and it will depend on what type of data you are sending to the database and whether you require ordering and things like that. But from there, you can connect your Lambda and control the batch size and the messages coming through, and that way you have the ability just to sort of control that and how you feed data down in your downstream systems to your database. So you can see here in this diagram that underneath the hood, Amazon or whatever cloud platform provider you're using will poll for data coming off that stream and then send the data through to your Lambdas. So now that we know about how to tackle the bottlenecking problem, how do we actually go about achieving scale? So we're going to look into two things. We're going to look into streams and queues, and the first thing we'll look at is a Kinesis stream. So it's a great way to process data quickly with very little effort, and lambdas read from the stream and invoke for further processing. So lambdas read off data in batches, and there's two ways you can configure your lambda functions to interact with your stream. The first is a standard iterator pattern, in which a lambda will poll for data on each shard every second at the maximum batch size that you have configured in your application. And you can see here, you've got a lambda, it's connecting to a shard, and that's coming off the Kinesis stream. However, bottlenecks can actually still appear using this design pattern, as the read throughput is shared per lambda per shard. And what I mean by that is, for example, if you have a shared data stream, such as the Kinesis stream here, it might be shared between you, your team, and another team, might be on the same account, and you can't control other people connecting into that stream, your read throughput is going to be shared out through those lambdas connecting to that stream, so it's something to be aware of, and that can cause bottlenecks in your application. But there is a better way to tackle that, and that's using the stream consumer pattern, where you still have the Kinesis stream, but you start sharding out your application, and each shard contains a maximum number of batches, and you can dictate the maximum number coming off those shards through configuration, and each shard has a dedicated connection to its own lambda, and that's great if you have multiple applications reading from one data stream, or you are reprocessing large amounts of data. So we saw this pattern being used where Kinesis streams will hold data for up to 24 hours, but if you want to replay everything from back 24 hours ago right up until this point, it's a great way of processing through that data really, really quickly and scaling out as well. Just got some key takeaways here. Things to remember is that batch sizes are limited to 10,000 messages per batch. The total batch size cannot exceed 6 megabytes. So that's something we had been caught out with before when delivering at scale. And also to keep in mind total invocation time. And what I mean by that is you've got your lambdas and they're consuming data off your streams, but it's also about how long your data transformation is taking inside those functions, and then also how long it takes to get into your data store, and that can actually affect scale as well. It's something to keep in mind, that you want to try and make your data transformation as light as possible. So moving on, we've got queues, so simple queue service or SQS. It is a great way to process small pieces of data with very little effort. Lambdas poll and invoke for further processing. So we have a first in, first out principle here, where a lambda will long poll on the queue and wait for a maximum of 20 seconds. So within that 20-second period, any information that comes through, it will then grab messages off that queue and process. But the better way to handle this is with batching. So this is the first in, first out principle with batching. And with each batch, you get a dedicated lambda connection coming off that queue. And you can have a maximum of 10 messages per batch. That's like, it's smaller with queues, but it still allows you to give you scale. So if you're not batching, you're only limited to 300 messages per second, versus if you batch, you're a maximum of 3,000 messages per second. So you can sort of see the scale that's achieved just from utilizing batching in your design. So you go tenfold from 300 to like 3,000. So that's pretty amazing. Some key takeaways, as I mentioned. Only 10 messages per batch. Total message size cannot exceed 256 kilobytes. That's quite small pieces of information. So I wouldn't, you wouldn't use this kind of thing to send large amounts of data, but it's good for like letting other things in your serverless ecosystem know something has changed. And I recommend batching all of the things. There's another hot tip. So to really maximize scalability, you should really utilize Lambda's reserved concurrency configuration. This allows you to have dedicated connections and stop other functions from preventing your most important functions from scaling up when it's needed the most. And it can also allow you to control the maximum amount of that your system can scale. So, for example, you don't want things to scale out of control. There's actually a thing that can happen now. Cloud providers are so good at doing this for you that it can actually scale out of control, and you may not necessarily want that. You may want to limit what's going on, and also it's really good if you've got a shared account, which most organizations tend to have, and you've got lots of other things going on. You want to dedicate your Lambdas to your most important pieces of information coming through. Then you can say, hey, I'm going to dedicate this amount of resource, and this is priority for all the data that's coming through, so that you don't end up scaling too much or too little. So I really can't believe over the last year, all of these great design patterns that are now available to help you build truly concurrent and scalable software. However, the questions of how do I know where best to set my reserved concurrency limit, or how many shards do I need best to serve my application needs, they're still questions that need to be answered, which leads me on to my third point, which is testing for scale or trying to predict the future. So problems. How do you know you no longer have bottlenecks when you're designing your applications? Solution, performance testing. So the first question to ask about how do you know that you may or may not have a bottleneck to occur, there's two very different approaches to this, and I've seen both of them in my time working in various different teams and working on serverless applications. So the first one is being reactive, which is essentially opening the floodgates to your end users in production and being reactive to when or if a bottleneck occurs. I don't recommend that. I see this happen all the time. It's just like, yes, cloud providers are going to just help us and it's all going to be done for us and we don't have to do anything, until all of a sudden you've got error messages popping up saying that there's only so many connections going through to the database, or the shard iterator is backing up because there's a bottleneck going through your applications off the queue because you haven't batched enough or you haven't sharded enough. So the next option, and this is the preferred option, is to be proactive. And that's by basically performance testing. I can't reiterate that enough. Is super, super key. Like, it's the key thing to do when you're building out things for scale. So there's some tools available to you to help you achieve this. And the first one that I highly recommend is called Serverless Artillery. So artillery.io is actually a performance testing tool for standard applications, but a company in the States called Nordstim has, this is all open source by the way, has forked that code and made their own repository dedicated to performance testing serverless applications. So it's all available on GitHub. I highly recommend checking it out. They have great demos, great tutorials. There's a whole page of things that you could spend probably about, I don't know, a week going through all their demos and tutorials. It's highly recommended. The next option, which I personally haven't used myself, but other people I know within Xero have used JMeter for testing serverless applications, which is also another viable option. And last but not least, rolling your own, which is kind of a weird thing to put up there. But don't be afraid to do this. So 2 years ago, when we were building out the webhook solution, my team needed a way to prove to management that as soon as we go live, we weren't going to run into problems, as this was our first ever serverless application. So people were very skeptical about it, as managers tend to be. Sorry if there's any managers in the audience, but it's kind of true and I understand why. So we needed a way to be able to confidently say, yes, we can handle up to those 1 million invoice changes an hour. And yes, we can handle up to our top 10 app partners becoming subscribers to our platform. And all it took was 2 devs and 1 week, and we were confident that we could scale concurrently as well as horizontally. We were also able to identify potential problem areas and at what load they were going to occur. So we were able to predict our breaking point. What does our breaking point look like? Okay, so we know that our current load going through production is X amount, but what happens if we double that, triple that, 5 times that amount? Where is the point in our system that it's going to break, and where is our weakest link? So 2 years on, and to this day, our original estimates were bang on, and we've never had an issue with an increase in subscribers or messages delivered. As you saw by those numbers, when we keep scaling up, we've never had any issues because we sat there for a week and performance tested, and we just chucked everything we could at it to see, okay, well, there's a bottleneck here, how do we deal with that? Oh, okay, so we're going to have to add more shards to our Kinesis stream. What happens if we increase the batch number of the messages being delivered or decrease it? We were just playing around with everything that we could to see where was the weakest point, how much we could deliver, and give that confidence to our managers that, yeah, this is the right approach to be going down. And in my time building out these applications, I come across something else that I call scenario testing. So it combines performance testing with infrastructure as service code changes. So for example, if you are changing the batch size on a Kinesis stream, or you're adding another Lambda to the mix, or perhaps you're swapping out data stores, all of these changes are like individual scenarios, and they really need to be captured and performance tested again and again and again and individually. Because it would be a little bit foolish to assume that just because you've got this like architecture and it's in production and it's serving data, that when you make a change to your application that you haven't shifted a breaking point or you haven't caused a bottleneck somewhere else in the system. So you should be consistently going through your performance tests with every sort of infrastructure change that you do. And with that said, that's pretty much everything that I have. So we've covered off how scale is defined. Concurrency, remember, concurrency over the total number of requests is what you want to focus on and what you want to design for. Scale through streams and queues is the way to go about that. And future-proofing your code from bottlenecks by performance testing and using those amazing tools that are available to you. So that's the end of my talk. You can find me just hitting up my work email address if you want to have more chats about what I've been working on, or performance testing and how to get results, and really how to get your serverless applications humming while you're sleeping and not having to worry about it anymore. Is there any questions? Yes.
How are you monitoring in production? Basically.
Yep. Oh, so the question was how we're monitoring in production. So we use a combination of dashboards. So we have like an external dashboard system. So it's going through CloudWatch, and then that's sending information from CloudWatch into New Relic dashboards, and I think we used to use Datadog dashboards as well. We also have alerting that goes through to our Slack channel. So we have tolerances set on all of our serverless components, and if they exceed a threshold, say for example, we don't want our Lambda iterators from the Kinesis streams being more than maybe 30 seconds behind, we'll start getting notifications to our Slack channels, and then that can integrate into our PagerDuty system, which whoever's on call would get a notification sent out. But in the time that I've worked on this project and been at zero and being on call, there's been never one PagerDuty alert for that particular system. So some other things maybe, but not this, which is great. Any other questions? Nope. Awesome. That's it.